Hi, I'd like to talk to you today about CQ Maven methods. This is a recording of a talk that I delivered at CQCon in 2013. My name's Andrew Savoury. You can email me at asavoury@adobe.com or you can find me on Twitter at savs. If you've got any feedback you'd like to give about the talk or if you've got any questions, please do feel free to get in contact with me. So I joined Adobe in November of 2012, and when I joined I was very much a CQ newbie. Although I was aware of the product, I'd never actually used it. I was however a JCR, a CMS and a TLA old hat. My background was very much in open source software projects, in content management systems and in developing mobile platforms. And today I'd like to talk to you a little bit about what I've learnt so far in terms of building projects using CQ. If you find any mistakes in the talk or if you'd like to provide some further material for the talk, please do find the talk on GitHub and I'd be happy to accept any patches that you'd like to send in. If you'd like to follow along with this talk in your browser, you can go to this URL and you'll find the talk online. And the final URL I'd like to share with you is planetcq.org. This is a blog aggregator of all of the blogs related to Adobe CQ, and if you have a CQ blog, please do feel free to get in touch and I'll add your blog to the aggregator. So when you start using CQ, the first thing someone will probably ask you to do is to build a CQ site. And you might say, well, where on earth do I begin? If you've got a little bit of CQ experience, you might fire up your CQ instance and point your browser at it and start using CRXDE Lite to develop components, templates, maybe even full projects. And this is fine. CRXDE Lite is a great in-browser editing environment and development environment, but there are a couple of limitations to this approach. Now, if you're a guru, if you've been on perhaps the developer training, if you've got a preference to using desktop development environments, then you might say, well, I'm going to use Eclipse and I'll use CRXDE with Eclipse. Perhaps you're more hardcore than that. You might say, well, I'm a ninja, I'm going to use Emacs and VLT and that's all I'm going to use to develop my CQ site. Or perhaps you're a guru ninja and you might say, no, I'm going to use Vi and I'm going to use curl to build my CQ site. Or perhaps if you're a real hardcore programmer, then you'll do it the old school way. You'll wave a magnet over a hard disk to align the magnetic fields to develop your CQ site. And for more information on real programmers, please take a look at this XKCD comic. So these methods all work for developing CQ projects, but what about reverting mistakes? If you have an error, how do you go back to your last known good version of the code? What about reproducible builds? How do you make sure that it always works on your system? And what about collaborating with others? How do you share your code with other people so that they can develop the site as well? And once you've developed your site, how do you go about deploying it into production? Pretty soon you might find yourself saying, you know what? Why isn't it easier to build a CQ site? Why does it take so long to get a project up and running? Why is it that no two projects you create are quite the same? You have some slightly different folder structures perhaps. Why is it that other people don't know your project layout? They come along and they start looking at the site that you've just built and they don't know where you've stored things. Why is it so difficult to figure out what your project dependencies are? And why is it so difficult for others to reproduce your site, to get it up and running on their machine? Why is it so very difficult to test the site that you've built for CQ? And why is it that you have to read lengthy documentation in order to use the site? Or even worse, there is no documentation and no information about how to use the site. Why is it that you're writing lengthy documentation to deal with the lack of conventions around building a CQ site? Now, pretty soon you might say, you know what, CQ sucks. But actually, with these problems you could end up saying the same about any product. Any product might suck if you're seeing these issues. But actually, it's not a question of the product sucking, really it's a question of your methodology that sucks. Sorry. So how do we go about fixing this? Well, we're going to use three things. we're going to use Maven, we're going to use Git or Subversion or CVS or Perforce, your mileage may vary, and we're going to use best practices. So what are these things? So if you're not familiar with it, Maven, it's a software project management tool, and it's based on the concept of a single file, a POM, a project object model, and it helps you with the build and the reporting and the documentation and the deployment of your projects, all from that central project file. Git, it's a free and open source distributed versioning system that's great for small through to very large projects, and it works with them speedily and efficiently. And if you're not familiar with version control, it's a system that records changes to a file or a set of files, which means that you can recall those versions of those files at any time in the future. And finally, we're going to use best practices. Now, best practice is simply a method or a technique that's been consistently proven to deliver results that are superior to those achieved with other means. Now, importantly, with best practices, a best practice can evolve and can become better as improvements are discovered in your working methodologies. So what is it that we actually want out of this? Well, we want to have minimal customization when we're creating a CQ project. We want to have a standardized way in which we can create our projects. We want a standardized way to build a project, to deploy a project, to test a project, to share a project. And this is the perhaps ideal scenario that we're looking for, a workflow for creating and developing and deploying our projects. And how will we know if we've got it right? Because at the end of this you should be saying it's easy to build a CQ site. So let's get started. The first thing you need to do is to install Maven and to install Git. Now there's great documentation about doing that, so I'm not proposing to talk you through that today. Once you've installed Maven and Git, you need to do a little bit of configuration of Maven. Now Maven has a central settings file which defines things like what repositories it can use to download plugins, and this file is typically in your .m2 settings.xml, and the first thing we need to do to that is to add a profile that will point to the Adobe repository. Now this profile explains to Maven where it can find the Adobe plugins, and we're going to be specifying that repository a little bit later on when we start using the Maven archetype plugin. So to configure the repository, you need to add this to your settings.xml file. I don't expect you to be able to read all the way through this. You can find it on the talk online, and you can also find it at the various websites that are referenced in the talk. Now once you've added your Maven repository, the next thing you need to do is to enable the repository so that Maven knows it can use it. And you do that by adding this active profile snippet to your settings.xml. Now if you're working with lots of repositories, you might like to leave the Adobe repository inactive and then specify it using the -p option on the command line to activate the profile. And this will make Maven work just a little bit quicker when you're doing tasks that involve multiple repositories. So the next thing to do is to start using Maven. Now when you're starting a new project, whether it's in CQ or perhaps on other platforms as well, it can sometimes feel just a little bit like you're having to reinvent the wheel each time you create a new project. So here we're at the start of our typical or our ideal workflow that we're trying to develop. The question of generating a project from a Maven archetype. So what is an archetype? Well, an archetype is a very typical example of a certain person or a thing. It's an original which has been imitated, or a prototype. In the Maven context, it's a prototype upon which other projects are copied or patterned or emulated. And what CQ archetypes are available? Well, there's three main ones that I'd like to talk to you about today. The first one is the simple content package, and this generates a simple content package. Straightforward. There's the multi-module content package, and in addition to the simple content package, this also creates the folder structure that's required for developing a typical CQ application, which includes that content package and also bundles. And the final archetype is the CQ Blueprints multi-module archetype. And this is a third-party archetype that in some way encapsulates some of the best practices that have been identified when working with, for example, OSGI bundles, taglibs and CQ content. So just a little word about packages here. I've mentioned them when talking about the simple content package archetype. Packages are a way of importing and exporting content from the repository, the CQ repository. And you can use packages to install new functionality, to transfer content between CQ instances, or to back up your repository. Now, a package is simply a zip file that's in a specific format, namely the file system vault serialization format. And packages also include some meta information, for example, filter definitions, import configurations, and additional package properties. And you can manage your packages through the CQ Package Manager. I also mentioned bundles when talking about the multi-project Maven archetype. Now, a bundle is a modular container of functionality for OSGI containers. It's essentially a piece of a Java module that contains application logic, and that will typically be a number of Java classes and whatever other resources are needed in order to deliver that functionality or to provide services to other bundles. You can manage your bundles through the CQ web console. In CQ 5.6 and earlier, this was called the CQ OSGI console. So we now know about packages and bundles and archetypes. So how do you go about using an archetype in Maven? The command is very simple. It's just Maven archetype generate, and then a number of properties that you need to use to configure it. So the first property is the archetype group ID, and this identifies the group of archetypes uniquely across all possible projects. The next is the archetype artifact ID, and that's the name of the specific archetype that you want to use without any version number. You specify the version number separately, and the final property you need to specify is the archetype repository. And this is where you would get the archetype from, and it's based on the plugin repository that you add to the settings.xml, which we edited earlier to include the Adobe repository. So let's go back to the simple content package archetype. From the manual, this creates a Maven project that's suitable for installing resources for a simple CQ application. And the folder structure that's used, that's created for you, is what you would typically find under the /apps folder of your CQ repository. And the POM that it generates provides commands for packaging the resources that you've created and for installing those packages onto the CQ server. So let's take a little look at how you would go about using this. So as I described before, you use the Maven archetype generate command, and here we'll specify the group ID as comday.jcr vault, and this is the unique group of packages for dealing with the Adobe repository. And then you use an artifact ID of simple content package archetype to uniquely specify the archetype that you want to use. And finally, you specify which repository you want to get the archetype and the artifact from, and that's the Adobe Public Releases repository that we configured in our settings.xml earlier on. So let's take a look at that in action. So here I have a console, and I'm going to enter the Maven command that we talked through earlier, and this is to use the simple content package archetype. Now, ordinarily you would see Maven go away and download the particular archetype that you've specified, but because I've been using it before, it's already downloaded it to the local cache. So then I can specify the group ID of my project, so let's say Adobe CQCon, and then I can specify the artifact ID, and I'm going to call it CQ demo. The version, we can just accept the default here, 1.0 snapshot is perfectly reasonable for a new project. And the package we don't actually need to specify here for the simple project archetype. This is something that Maven requires you to fill in, but the simple content package archetype doesn't require it. The apps folder name, this is where the project will appear under the apps folder in CQ. So let's just say CQ demo. And the artifact name, this is some additional information that will show up in the package manager under the package description. So let's say this is demo app for CQCon. And finally the package group. Now this is where it shows up within the package manager. So let's enter CQCon for the group, and Maven will prompt us to confirm that we're happy with our choices, so let's just go ahead and say yes, and it's gone away and it's generated our archetype. Now if we take a look at what it's generated, you'll see that it's set up a bunch of default folders for us. If we look at that in a little more detail, you'll see that it's also set up some default files in there for us as well for creating our CQ project. So, as I said, when using the command, the group ID is like a package name and it specifies your project uniquely across all possible groups. And we used Adobe CQ demo. The artifact ID is the name of the jar that will be produced without the version number, for example, my project or CQ demo. The version number can be anything you want, but the default is typically fine for starting new projects. The package name is not used in the simple content package archetype. The apps folder name is how your project will appear under /apps, so apps my project or apps CQ demo. The artifact name is shown in the package manager under the description field, and the package group is how you can identify or find your project in the package manager. And the typical output that you would get from the simple content package archetype is a set of template directories and template files. Also the pom.xml file, your project file, which provides instructions for compiling your project, for creating bundles, and for also deploying everything to CQ as packages. It also includes some file vault configuration files, which we'll talk about in a little bit more detail later on. If you wanted to use the multi-module content package archetype, the command is pretty much the same. The only thing you would change is the artifact ID to reference the multi-module content package archetype ID name. The output you get from the multi-module content package archetype is slightly different. So as well as our content directory, as you found in the simple content package archetype, we've also got the relevant directories for creating OSGI bundles, so source main Java directories and source test Java directories, and pom.xml files required to build both the bundle and the content package. If you wanted to use the CQ Blueprints multi-module archetype, you need to do a little bit more work. The first thing you need to do is to add the CQ Blueprints Maven repository to Maven settings.xml, in just the same way as we added the Adobe repository at the start of this talk. Once you've done that, you use the Maven archetype generate command as before. We do also need to specify -p CQ Blueprints to say we're going to use the CQ Blueprints Maven repository profile that we set up, unless of course you've set it as active. And this time the archetype group ID is CQ Blueprints archetypes, and the artifact name is multi-module, the version number 1.0.5 or whatever's the latest version, and the repository that we've configured in our settings.xml, so in this case CQ Blueprints plugins releases. The output you get from the CQ Blueprints multi-module is slightly different to the previous two archetypes. So here you'll find that everything's divided into specific directories, so we've got a config, a content, services, taglib and view directory. So why would you use the CQ Blueprints multi-module rather than perhaps the simple and elegant Adobe archetypes? The guys at Headwire who created this archetype say that they wanted to consider with this archetype the concerns that they have to address typically in working in some large teams, based on their experience of developing CQ projects. And the way they've done this is to split up various areas of concern. So for example, the CSS, HTML and JavaScript front-end developers can all work in the Vue subproject. The Java developers doing the back-end work can work in the taglib and the services directories. All of the configuration files are stored in a separate project, and then you have the content directory for getting content quickly on to the developer's box, and so on. So that's working with CQ and archetypes and Maven. Now let's talk a little bit about Git. So first of all, why would you actually want to use Git or any version control system? Well, primarily this provides you with a local safety net, so if you make any errors you can just roll back to a previous version of your file. You can also push your Git repository up into one of the services online like GitHub or Bitbucket, and this means you can use the internet as your backup, so you don't need to worry quite so much about local hard disk failures. By putting your code into Git, it allows you to share it with other people, and then as part of enlightened self-interest, hopefully those other people will start fixing bugs and contributing new features for you. So this brings us to the next step in our ideal workflow for working with a CQ project with Maven, the commit to Git section. So in order to place your project into Git, it's very simple. All you need to do is change into the project's directory and then type git init. And this will place your project under Git's control. The next thing you should do is to edit your git ignore file, and this tells Git what files you don't want to place under version control. And typically here you'd find Eclipse metadata files, you'd find the output of compilation, but we also need to add the VLT directories. These are the directories created by the file vault tool, which contain metadata about the interaction between the local file system and your repository and aren't really relevant for versioning. So once you've created your git ignore file, you can go ahead and add all of your project's files to Git, and you do that just by typing git add star, and then you can commit them to Git with some sort of meaningful git commit message. As a final recommended step, you don't need to do this, but it really helps. You can also push your project up onto a service like GitHub. Now, if you're familiar with Git, you probably won't recognize this GitHub new repo command. It's actually a sneaky shortcut which does the work for you of creating a repository on GitHub and then pushing your local repository up to that. If you didn't use the hub new repo command, you would typically have to go to the GitHub website, create a new repository, check it out on your local file system, merge it with your existing code, resolve any conflicts, and then push all of your code back up to GitHub. That's very long-winded, and this shortcut takes some of the effort out of that for you. So let's take a look at this process in practice. So here we have our project directory, and I'm going to change into the project directory. And then the first thing we need to do is to actually initialize it so that Git knows that it should be using it. So there we go. Your project is now available to work with Git. So the next thing we want to do is to create our git ignore file, and the things we want to add to that are typical files that are created as part of project development. So class path project, we want to ignore all VLT directories, which are just basic metadata directories, and any outputs from compilation. So now we can see what files are not currently available in Git, and then the next step should be to actually add those files to Git. So if we add them and then check the status, you'll see that all of our files are now ready to commit to our repository. So all we need to do now is do the git commit command, and you'll see that Git's put all of those files into version control. Now this commit is only local, and we want to put the files onto GitHub as well. So first of all, let's take a look at my list of GitHub repositories, and you'll see that there's no CQ demo here. So we can then run the GitHub new repo command. It prompts me for my password, and then it goes away and it does all of the hard work of creating the repository remotely and pushing my changes up to GitHub. So if we then go back to our GitHub window and refresh, you'll see that we now have the CQ demo project that's been added for us using the GitHub new repo command. So that's great. That's really straightforward and simple. Now typically, as time passes, you would be adding and editing and deleting files within your local repository. And then once you're happy with the changes that you've made, you need to add those files back to version control. So you would add any files that you've changed, and then you would commit them, and then you would push them back up to GitHub. So that's working with Git and Maven projects. Now let's talk about practices, perhaps best practices that you can use to develop your projects. So now we're at the build and deploy to development instance section of our ideal workflow. Now Larry Wall once said that the 3 great virtues of a programmer are laziness, impatience and hubris. So as we go through this next section, I want you to constantly think about how you can make things easier for yourself, how you can make things faster, and how you can make things better. CMS Borak claims that you have to be really people think you have to be really smart to use CQ, but in actual fact you just need to click much faster. Now clearly he's doing something wrong. He's not being lazy or impatient or thinking he can do things better. So let's take a look at how we can do things better in our workflow. So the first thing you need to do once you've created your simple content package is to consider building it. So how can we build smarter and faster with less clicks? Well, using the Maven archetype that we've created, we can use the Maven package command to build our project. And this will create 2 outputs. The first is a content zip file, which is the content package, and the second thing it will create is the bundle snapshot file, jar file, which is an OSGI bundle for our project. But what about deploying? Well, we could take that package file and that bundle file and we could upload that to the CQ package manager or the CQ web console, and we'd have to do quite a few clicks with our browser in order to do that. Is there a way we can build and deploy smarter using our Maven workflow? Yes, there is. We can use the auto install package profile, which has been created by our archetype for us, and that will automatically install our packages and our bundles into the CQ repository. If you're using the CQ blueprints archetype, there's a slight change in the way you specify that. You specify auto deploy rather than auto install package or auto install bundle. So let's take a look at how that works. So here's our CQ project that we created earlier, and here's the package manager. Now as you can see in the package manager, we don't actually have any packages in there now from our CQ demo. If we look under the group CQCon, you'll find there's no CQCon packages in that group. Now normally you would have to upload package, search on your local file system for the location of the package, and then click on OK, and install. Now that's lots of clicks. So is there a faster way? So the way we would do this is simply to type auto install package and then install, and Maven will take all of the hard work of installing the package away from us. And there you go, it's as simple as that. And you can see here at the very bottom that it's installed our package onto our local instance of CQ. If we go back to the package manager and refresh, you'll see that our demo archetype package has been installed. And you can see the artifact description there, and you can see that it's in the CQCon group that we specified earlier. So that's how easy it is to build and install and build and deploy using the Maven archetypes that we've used. So what about the development process? So we're now at the point in our workflow of the developing CRXDE or CRXDE Lite and using the VLT tool to synchronize with our local file system and to commit with Git. So in a world of Maven archetypes and builds and deploys and using Git to keep track of all of the versions of our files, how do we go about doing development? Well, we can use the File Vault tool to help us with this. You can use the File Vault tool to check in, check out, update and synchronize local content with the content of your CQ repository. Now the File Vault tool is available within the CRX Quick Start directory. If you look in /opt File Vault, you'll find a .zip file and a zip file there. Now extract whichever version is relevant for your platform and make sure that it's added to your path, and then you can simply use the VLT tool as shown in this example. VLT with the credentials to talk to your repository, and then the command that you want to use, check out, check in, update, and then the CRX repository address. So a sample development workflow that you could use with Maven and VLT and Git is to use Maven to create your project from an archetype, then use Maven to build and deploy your project into the repository. You would then initialize VLT to tell it that it should be working with your repository. You can then create components and templates and so on with something like CRXDE Lite in the repository. You would then use VLT to copy those files back onto your local file system. You can optionally change those files on your local file system if you like, and then you can use VLT to copy those changes into the repository, and you can also add those files into Git. So let's take a look at that now. So we have our archetype generated project here. So the first thing I'm going to do is to change into the VLT directory, and here you can see we've got some sample files which have been created in our package, but we don't have any of the VLT metadata files. So the first thing we need to do is tell VLT that this directory is actually under File Vault's control, and to do an initial checkout of our repository into the file system. We do that using the checkout command and specifying the URL of our repository. Now you see that as well as recognizing the files that we had on our local file system, it's also created some .content.xml files as well. And these .content.xml files contain all of the nodes and properties that are not compatible with a file system, but still exist in the JCR repository. We need to place all of these files under version control, so let's go ahead and do that now. And then we can do commit to make a note that we've started using VLT. So there we go, the metadata files are also being versioned. So now we can go into CRXDE Lite, and we can find our CQ demo project here, and let's go ahead and use CRXDE Lite to create a sample component, and let's call it demo, and accept all of the defaults and save it. And there we go, we can see our sample component doesn't have much in there. So now let's switch back to our local file system, and we want to get a copy of our component on the local file system. So all we need to do is type VLT update. That will go and pull all of the changes that have been made to the repository and place them on the local file system. And here you can see that we have our demo.jsp. So now we can edit that file and add some content to it, and then we can push that change back into the repository. If we go back to our file, and if we do a refresh, there we go, you can see that the file has changed from the file system pushed into the repository. So we're happy that our file system contains the latest version of the file, so we can go ahead and put that into Git, and we can then add that to our local repository, and let's just push it up to GitHub as well. There we go. So that's development using Maven, Git and File Vault. What about testing? Now, testing is an enormously complex subject which I don't really propose to talk you through today, but as a few hints, you could look at doing some continuous integration. You can use Jenkins with the Git plugin and the GitHub plugin. You can run Selenium as a server to do web testing, and you can use something like Cucumber for Java with the Jenkins plugin and create all of your tests in Java. But for more information on integration testing frameworks, you can take a look at the talk done by Lydia as part of CQCon 2013. Now, what about pushing your code into production? When we're using Maven builds and deploys and Git saves and VLT, how do we move our project to production? And this brings us to the last step of our ideal CQ project workflow, the push to production step. Well, there are many ways you can do this. It will depend on your project architecture and your deployment methodology. One way you could do this would be to add an extra profile to your project's pom.xml file, which specifies the address and the port of your production server, and then you can deploy to production simply by referencing that profile when you're using the install command. You could also do a one-time override of the host and the port properties when you use the install command, as shown here. And for more information on testing your deployment and making sure it's healthy, you should take a look at Bertrand's talk from CQCon 2013. So let's put it all together. We'll go from 0 to 60 miles an hour in 5 pseudo lines of code for building our typical CQ project. So, to create a project from scratch with a fairly standard layout, you can use the Maven archetype generate command. To get your project under version control, you do git init, git add, git commit, boom, your project is under version control. To automatically build and deploy your project, you use the Maven -p auto install package install command. To synchronize your project between the repository and your local file system, VLT checkout, VLT update, VLT commit. Once you've done some development, make sure your repository is make sure your code is up to date in Git, git add, git commit, git push. And that takes us to the end of our ideal CQ project development workflow. If you have any questions, please do feel free to email me at asavory@adobe.com or get in touch with me on Twitter. And that's the end of the CQ Maven Methods talk. Thank you.